Welcome back to the Aussie Shed, ladies and gentlemen, for another episode of Project Fairlady. In this episode, I'll be doing a bit of turbo mock-up work, amongst other things. Now, if you're a follower of the channel, you'll probably remember what the turbo setup was like on this thing when we pulled the motor out of the car. It was absolutely atrocious, the way the wastegates were mounted. There was crap welded onto the turbos that just didn't work. Basically, it was just one giant clusterfuck. So what I'm going to do is I'm going to go through and I'm going to fix all of those issues. My motivation for doing this, folks, is I want to get all this stuff finalised before I send the turbos out to get the new billet wheels put on them. Just so that, once they're finished and set up and all nice and clean and ready to go, I'm not mucking around with cutting and grinding bits of pieces and really handling them and stuff as well, because I am going to get the exhaust manifolds and the turbine housings ceramic coated, so I don't really want to be handling those because there's more chance of me bloody scratching them and making a mess of them and all that sort of stuff. So what I want to do is get all the fittings worked out, get all the new lines and everything made up, and the main thing I have to do is sort out the wastegates, because the wastegates were just absolutely atrocious in their setup previously. Those of you with a keen eye will probably notice the Bda Engine Mounts there. They're going to be crucial in setting up the inlets to the turbos and stuff, because they're just ideal for in a situation like this, where you're running aftermarket turbos, which is part of the problem that they had with this initial setup. Is they had standard engine mounts and they were very restricted in how they were able to get air in and out of the turbos. It was just a bit of a joke, really. So the first thing I'd like to go over, folks, is mounting the wastegates and the theory behind it, and why we're going to be doing things in a particular way and what you're actually trying to achieve. So let's zoom in a little bit and change our angle so we get a bit better look at what I'm talking about. Right, folks, so this is the wastegate for this side. It's the one that was originally mounted on this side of the engine. I have fixed up a few things with it, cleaned it, polished it up and everything, so that it is, and tested it just to make sure that it is completely usable. So what I've got to do now is work out where exactly I want to mount the thing. Now, the original bracket that was on here was a half-assed piece of crap made out of a couple of really badly bent up bits of steel and in a really bad position. It just really, really didn't work, It was terrible. It was absolutely terrible. They had the wastegate mounted sideways, and you can see they've actually bent the nipple on it because it was actually hitting the chassis of the car instead of orienting it the way that it's meant to be, So ideally what you've got to do in a situation like this, folks, is you've got to work out the position of your wastegate, where you can actually fit it, where it's going to work on the car, where it's going to give you clearance and all that sort of stuff, Make sure you've got clearance for the nipple on there for your hose to go onto, and also that it's actually going to work properly, And realistically, the wastegate can be mounted anywhere as long as you adhere to certain sort of principles. Now, the wastegate can be down here, it can be, it can be here, it can be basically anywhere in a 360 degree radius around the wastegate pivot, as long as when it's finalized, the arm that works the wastegate is at 90 degrees to the wastegate pushrod arm here. For example, like that, as in not, it can't sort of be like that when it's attached, and it can't be sort of, the opposite way sort of thing like that. All aftermarket turbos come with the wastegate lever arm welded on in just roughly this sort of position where this one is now, slightly over 90 degrees off the face of that. But that doesn't mean that that's where it has to stay. Standard practice is to grind that weld off, remove this lever arm, and reposition it to where you want it and re-weld it. It's something that you pretty much always have to do. You very rarely get lucky that it's going to work 90 degrees off this arm all the time. You can sort of take that into consideration when you're working out the position for your wastegate actuator, but a lot of the time it just simply doesn't work. As you can see here, to be 90 degrees off that in the closed position, the wastegate would have to be here. Now obviously if the wastegate is going to be down here, then that lever arm needs to be removed and repositioned. It's actually also bent. Why it's been bent, I have no idea, but I'll straighten it out when I sort of take it off. But when it was actually on the car, it was sort of mounted in a really weird sort of cockeyed position down here. So this angle was sort of like that. What that does is it decreases your holding force against the wastegate flap. So when exhaust gas enters the turbine housing here, it puts pressure on the wastegate to try and force it open. And the way to maximise the capacity of your wastegate actuator is to be 90 degrees. That gives you the most holding force in relation to this, which is why you put it in that position. And you also want them both to be the same. So you want both turbos operating identically at the same pressures and all that sort of stuff. You don't want to be favouring one turbo over the other. So the first thing you've got to do is say, okay, well, where's the optimum position? Where's the ideal position that I want to mount the wastegate? And for me, it's pretty much about here, I think, is where I'd like to mount the wastegate. I've taken a few measurements and I have got clearance against the chassis rail in this position over here, and it just sort of works for me. But as you see, this angle here is wrong, so I'm going to have to remove this lever arm and sort of re-weld it. So how do I go about setting out a bracket to mount the wastegate? Well, of course I'm going to do what I always do, folks. I'm going to make a template out of cardboard, and then I'm going to reproduce it in steel. So I've already made a bit of a template for this, so I'll go and grab it off the bench and I'll give you a bit of a look. So this is the template that I've made here, folks. It's just a piece of cardboard, just like a cereal box. Actually, it looks like a bloody Pepsi box or something like that. You want to get onto at least 2 bolt holes here so that you've got good fixing for this thing, so it can't pivot around and all that sort of stuff. You see so many people try and modify a standard wastegate actuator bracket that they might get with a wastegate and put together some sort of a compromise. It just doesn't work because they couldn't be bothered making something new from scratch. And folks, you just have to. There's many times you just have to make stuff from scratch. You've either got to do it yourself or you've got to pay someone to do it. So that's why I'm showing you guys all this sort of stuff, so you can learn to make stuff yourself. It's the only way you can become really serious about building cars, unless you're a friggin' very wealthy person. Okay, so bit of cardboard, 2 bolt holes. Where are we going to do it? That's roughly what I want there. So as you can see, that gives me a position here where I've got something to bolt through to hold my actuator arm in the right position. Obviously there's a lot of trial and error with the cardboard to get it exactly where you want it and all that sort of thing, just to make sure that you've got the angle of the rod right and all that sort of thing. And once you get it made out into cardboard and you're happy with the shape of it and everything, you then just transfer it onto a piece of steel. So let's go over to the bench and have a bit of a look. Alright guys, so what I have here on the bench is just a piece of mould steel. It's, what do we got? It's about 2.7, 2.8 mil thick. Just a piece that I had sitting there under the bench. I just buy bits and pieces like this for this exact purpose, and try to keep stuff around so that I'm not sort of hunting for stuff when I need things. You can see I've already cut a few bits sort of off here. So how I do this sort of thing, folks, so that I get a really accurate sort of an image of what I'm doing, I'll roughly lay it on and then I'll just get a big fat black texter and colour in everywhere where I'm going to be scribing, just because it makes your scribe marks stand out so much better, rather than just sort of scribing around this onto the steel. Just make sure you've got plenty of coverage. Let it dry off for a few seconds. Sit your cardboard on there once you've sort of flattened it all out, once you're 100% certain that it's going to be okay, and then just scribe around it. And this way you'll have a really nice, easy to follow line that you won't be squinting your eyes trying to look at when you're cutting it out. Beautiful. Now, I would probably cut this out with either a just a 4-inch handheld angle grinder or on the bandsaw, just depending, And once you've got it all cut out, you can then start bending it up. Now, you can just use a vise to bend it up, a vise and a hammer and whatever, The more tools you have, the better to be able to do this sort of thing, but you can get by with just some really basic tools to bend stuff up. But unfortunately, folks, I can't show you the bending because I've already actually done it. This is actually the piece that I made up from that template. Okay, now I did some of the bending on this in the vise. I do have a bit of a bender attachment from a hydraulic press that I also use to do a bit of the bending on it, but you know, it's very basic stuff, guys. It's very basic stuff. Whack it in a vise, you know, smash it over, move, you know, put the other bit in the vise, bend it back over, or use any sort of a bender that you've got available. Like, you really just don't need really expensive tools to do this. Transfer all your marks and your holes and everything onto your piece, and there you go. There's no way that the actuation of the wastegate is going to unbend any of this. It's just too heavy a gauge. You couldn't use aluminium in this gauge. You would have to use a thicker piece of aluminium to have the strength that this has. You know, you could use a bit of stainless, as long as it's quite robust. You know, you don't want something that's at all floppy. If you're stuck and you have to use something that's a little bit undersized, you can always weld a few gussets into it, you know, like little triangles in the corners and stuff like that to sort of strengthen it up. But ideally you want to use something that's about the right gauge, you know. Something between 2.5 and 3 mil I find is ideal for making strong little brackets sort of like this. So let's take it over, mount it onto the turbo, and see what it looks like. Alrighty, and I am cheating a bit, folks, because I already know this all works because I have already pre-fitted it all. But you know, it was a matter of fitting it exactly like I'm doing now, checking it, you know, maybe tap the bends around a little bit, have a bit of a look at it, and just go, oh, I wish I'd done this, wish I'd done that. Can I save it? Or do I have to make a whole new one from scratch? Sometimes you just have to abort the thing because you've made an error in your judgment, you've made an error in your template, you know, you haven't allowed for something or other, and you've just buggered it up and you've got to start again. Alright, so here's a wastegate actuator, which will just go in like this. And there we go. I'll get a couple of nuts on this and I'll have a bit of a chat to you about the top half of it. Alright folks, there we go. Now, as you can see, I'll get the camera over the top a little bit here. Now, as you can see, this angle is not 90 degrees, okay? We need this to be over here. So what we have to do is, as I mentioned earlier, grind this off, re-weld it in the right position so it's 90 degrees. But another thing you have to think about when you're setting up your wastegate actuator position is where the rod is going to cross over on the wastegate lever arm. Now, what I will generally do, a lot of people will say that you have to line it up with the stud that is on the actuator lever arm, which is just sort of means I've got to pull this one down a little bit. But the problem with doing that is, as the lever arm goes through its motion, it actually pulls up. So what I like to do is I like to split the difference between the pin on the arm and the pivot on the arm, and I like to line up with the center, because as you'll see here, that point moves up to here when the wastegate is open. So if you've got it set down here, and when the wastegate opens, the rod needs to be able to move up, and a lot of the time it'll start to bind on the bracket down in here. So what I'm going to do now, folks, is I'm going to grind this off and reposition it. So let's do that, eh? There we go. And there it is, folks. I'll just flatten it out a bit and we'll reposition it and weld it back on. Alright, that looks pretty good, folks. So let's go and refit it to the turbo. Alrighty. So we'll just keep our wastegate up and in the closed position and just sort of see if we can Tap it on roughly where we sort of want it. We can always tap it around once we get it on. Pretty good. Alrighty, so this is what we have to do now, folks. We've got to make sure our wastegate is shut. We want a little bit of clearance here. We don't want this to be down too tight, otherwise we're going to kind of jam the wastegate mechanism. We just want a little touch of clearance there. But what I'll do, folks, is I'll get the wastegate actuator arm back on and suss this out where we want to put it. And that looks to be about right there, folks. So you can see we've got a nice 90-degree corner here now. Wastegate's in the closed position, and that's exactly where it should be. And this goes to what I was saying earlier about the fact that you can position the wastegate anywhere as long as you correct the wastegate lever arm once you're finished, to give you that nice 90 degrees, to give you maximum holding power to keep this wastegate shut when there's a lot of exhaust pressure getting in there. So that's about where we need to be. So I'll just set up the welder and we'll get a couple of tacks on this, recheck it, and then fully weld it. So I've just got a little tack on there, folks. I'm just going to check it all now and make sure that everything's okay. The wastegate's able to move through its motion without any dramas, that it's actually sort of moving fairly straight, you know. I'll actually get this out of the picture for the time being, if I can. Right, that seems to be pretty good, folks. It's not swinging on a bit of a kilter or sort of, you know, a bit wonky when it goes. It's actually swinging nice and flat. The wastegate flap can move quite freely. We're not binding anywhere. So I think we're pretty good to go to just get a weld right around that now. And there we go, folks. As easy as that. Right, so let's get our wastegate actuator back on and see if we've done everything properly. So as I mentioned, folks, we've still got nice, easy, free movement with the wastegate flap there. There's still a little bit of a end float on this here. It's all good, you know. You don't want that to, like I say, you can put this down too tight and then possibly bind that up, which you don't want to do, obviously. And that's very good, folks. So as you can see, we're nice and square off there. Our wastegate's adjusted where it needs to be. We've got maximum holding force. Bracket clears, you know, and we're all sort of good to go. Now, when it comes time to tune these wastegates, they do need to be adjusted properly. The standard adjustment for an internal wastegate is 3 turns on the rod. So what you do when you're setting it up is you get your adjustment so the rod will just slip on, you know. Like I can lengthen it slightly, half a turn, and it goes on a little bit too easy for my liking. Turn it half a turn, and that's sort of good to go. So what you need to do now is to go 3 turns on the rod, shorten the length by 3 turns. So half a turn, 1 turn, half a turn, 2 turns, half a turn, 3 turns. Now that's where your rod needs to be adjusted before it's put back onto the wastegate arm there. So you need to either pressurize your wastegate or just pull against the spring to be able to get that back on there. Now this has got quite a heavy spring in it because they're 14 psi wastegates. So I'm going to struggle to get that back, and I'm not setting it up at the moment. So for the time being, I'll just re-lengthen it back to where it was so it can slip on with no dramas at all. And we're good to go, folks. So you can see why I wanted to do all this stuff too, folks, before rebuilding the turbos. No matter how careful you are, there is a chance of getting crap in the turbos. I'm probably not being as careful as I would be if I wasn't going to tear these turbos down and completely rebuild them. But yeah, you see the issue, so it's always a good idea to kind of do everything that you can you know, ahead of time, so that once the part's finished you don't have to frig around with it again. I'll be making all new AN lines for the turbos and everything. So now that we've got that one, folks, let's flip the engine over and have a look at the other side. So this is the turbo for this side, folks. You can see I've already done a lot of work sort of setting it up ready with all the AN hose ends and everything sitting on it ready to go. And you can see the wastegate is actually already mounted. So let's get this to the bench and just suss it all out. So again with this wastegate actuator, folks, exactly the same deal as I showed you on the last one. This is the cardboard template here for this guy. So again, mount the turbo, sit the wastegate actuator in there so you can work out what room you've got, where it needs to go that it's going to operate correctly, and then go about fashioning a bracket. And obviously, as I've shown you before, the first step is making a cardboard template. So that's what we've got there. That's the way it sort of went on. You can see it follows the same shape and everything. And then once it's done, same deal, put it down on here, mark it out, cut it out, bend it up, drill some holes in it, and then check your design. Make sure that it all does sort of go together. And if it doesn't, make another one. Start again. Don't put up with something that you've buggered up that's not quite right, because you'll be regretting it forever. So you remember where this one goes. It was in against the side of the engine where it was close to the block, and just the joke of the setup that was on there before. So this is the, you can see this is the old adjuster and the old bit of rod out of the center. Not sure if you can see the bend in that, but the rod's quite bent, and for some reason they've cut the adjuster down just so much that I just don't understand. Plus it's, you know, she's friggin' wonky. Anyway, so what I did, folks, I just got a bit of 10mm 316 rod and turned up a new adjuster to match the one from the other side that we were just looking at, that's in an unmolested condition. Just reproduce that out, a bit of stainless rod. Got hold of some 316 stainless 5/16 UNF threaded rod, which is what this is, and just made two new pieces, you know, for both turbos. They're roughly about that size, and these are just the original ones, I would assume. They're just mild steel. The adjuster is actually stainless though, so mild stainless sort of mixed together, and your end adjuster here, it's mild steel and it's zinc plated. So I've just replaced everything that I can with stainless, and I'll probably replate this end piece when it comes time. Where I worked out to position the wastegate actuator, it's pretty much 90 degrees on this rod here. Like it'd be probably 91, 92 degrees maybe on that corner there. But realistically, it's close enough, folks. It's close enough that it's not worth grinding it off and sort of re-welding it just to move it a fraction of a millimetre. So yeah, I got lucky, folks. I got lucky, which does happen sometimes. Alright, so while I'm here mucking around with the turbos, I thought I might as well just start sort of mocking up the dump pipes off the back of the turbos. The car had some mild steel dump pipes on it, split dump pipes, you know. They were pretty crap. They didn't fit. The car had a bit of sledgehammer work on it to make them fit, and I just didn't like the design of them. I thought they were very sort of amateurish. I don't know whether they were something that a friend made for this person, or whether they were purchased from a Z Motorsport professional, but in my opinion, they're crap. So bottom line, folks, I've decided to make my own. So I've got a bit of 10mm 304 plate here, and I've just cut these out just with a grinder and stuff. If you want to see how I go about doing stuff like this, I've got a whole video on how I made the turbo manifolds on my Nissan 370 GT. Exactly the same process that I've used to do these. Yeah, it's not that hard to do. Get some plate, mark it out, Bob's your uncle, away you go. So that's how they go on there. And the magic actually happens on the inside. I'll just pull that off, and you can see here when your wastegate opens, oh, the bar's getting in the way. And this is the issue with divided dump pipes, folks, for internal wastegates, that no one ever really seems to talk about. And the issue is that as the wastegate is opening, it very near blocks the access into this separate pipe, whereas what would normally happen is when you have sort of an open outlet here where the two join together, as soon as that's open, the wastegate air shoots sideways and goes across into your main outlet, which does create turbulence and disturb the flow of your main exhaust outlet out of the turbine, you know. Hence the whole idea behind the split wastegate, but it can also be quite problematic. So hence the reason why you can see all this porting that I've done here on the back side of this, and that's to allow more clearance for the wastegate when it starts to open, so there's actually somewhere for the flow to go, you know. So that's actually port matched to this inside shape here on the exhaust housing. But there's actually more that needs to be done, folks. There's more that needs to be done. So when I start building these, what I'm going to do here, I'm using a slightly larger pipe for the wastegate, and what I'm going to do is I'm going to squeeze it down across this way, which will then lengthen it in this direction, and then I'm going to grind down into this lower section here where the issue is with the wastegate flap. That point right there, where all that happens, where it gets real tight. Okay, obviously the exhaust gas can flow around once it starts to open and come out, but you know, you really want to help everything out as much as you can. And you know, for a little bit of extra work, it's really not that hard to do. So as I say, I'm going to squash the pipe and bring it down, so I'll actually be able to come down here, probably 3 or 4 mil, and get that clear open section opening up a lot faster than it would normally, to let those gases sort of come straight out. Because I am going to be putting a divider on the inside of this, which will wrap around the inside and create like a full circle around in here, you know, to sort of close that up. So that's just a nice smooth circle inside there, which stops any wastegate flow coming through the side and sort of prevents all that turbulence. But like I say, it does then restrict your wastegate flow from being able to shoot that way. It's now forced to sort of come out of here, which is what you want, but you also want it to be able to get out of there real easy. So when you see divided dump pipes, folks, for turbos with internal wastegates, if ever you see them without a divider on the inside of them, don't buy them, because they're just crap. So what happens if you don't have a divider, then as I mentioned, you open this, regardless if you've got this pipe coming off here, the exhaust flow is going to be going into here. Okay, it's not going to come out through here, because you know, we're talking path of least resistance. If you've got a big gaping hole through the side and hardly any room around here when the wastegate opens, it's coming through here. And as I say, the dump pipes that came with this car, separate wastegate pipe, separate main pipe, but no divider on the inside, so basically they're completely useless. You might as well just have a single pipe that merges together and just not have your separate wastegate pipe, because really it doesn't start to function until your wastegate's fully open, and then you know, that obviously becomes then the path of least resistance rather than shooting through the side. But you still have all the turbulence issues associated with this unless you put a divider on the inside. So you have to have a divider, folks. Alright, so on to another thing. Let's talk about AN fittings, and I'll just grab some of these off and I'll just give you a bit of a squiz. Now, these are the waterline fittings that I'm talking about here, folks. I'm using AN6 for my water lines. These are all full stainless fittings. These are actually a brand name fitting, and I was quite disappointed with them when I got them for a few reasons. Now, hopefully I'll be able to pick this up with the camera and I'll show you what I'm talking about. So if you look into that banjo there, folks, you can see there is a big burr right there. Okay, can you see that? And it's just hanging there, right? You've got to check all your fittings, folks. You've got to check all your fittings, because remember, no matter whose brand on it, most of this stuff just comes straight out of China. And you really have to have your wits about you and just check everything. Don't ever assume that anything's right. So this is going to have to be deburred, folks. Otherwise we're going to end up with shit that could break off at any time. So we want to get the hell rid of that. And this is another one that I've already worked on, and you can see the difference. That's nice and clean. There's no burr. Alrighty, now that's just one part of this. Let's go and have a look at something else. Alright, so this is the other half of the fitting, the banjo bolt. And there are two things wrong with this. Firstly, for this application, the hole is too small. And again, you can't see down in there, but there are burrs on the inside from when this hole was drilled through here. You know, it's just really, really crappy. Again, you got to inspect all this stuff, look for burrs, get rid of them, use whatever you can to get in there, to get down in there to get rid of them, or do what I've done here, folks, and I'll just show you one that I've modified. Okay, so on the left here, this is one that I've corrected, and you can see what I've done, folks, is I've opened up the hole through the center to give us a lot better flow. And I've deburred the edge, so we've got a little bit of a radius to feed the water in through there. And when I've done that, I've also deburred the hole on the inside to make sure it is spotlessly clean and free of any metal. So just a few minutes work to go from that, hole's too small, it's got burrs on the inside, to this, which is way better suited for the application. Decent hole through the middle and no burrs. So combine the two together, and we now have something that I am happy to put onto the turbo. Whereas when these things first came, looking like that, I just looked at them and just went, nah, you're freaking kidding. I'm not putting that shit on the turbo, and they need a bit of work. It just seems like you can't trust anything nowadays, folks. You really, really can't. Alright, so let's quickly bolt this turbo up onto the motor, and I'll show you that it fits, and I'll show you this clearance, and you'll be shaking your head at why the hell the other setup was there that you would have seen in the last video or the previous video to that. Alright guys, so here's our turbo with a wastegate mounted on it and everything, and we'll just put this sucker on. I'll just have to quickly whip this oil feed off, guys. It's in the way of the nut that I'm going to have to put on here. And there it is, folks. It's on, and it fits, and it actually has plenty of clearance. The areas of issue are the oil filter tree underneath, and obviously the engine mount. But I could have made this fit even with the factory engine mount, I reckon, just by dropping the wastegate actuator down, changing the angle of it. It shouldn't have affected it where the oil filter tree is. By sort of looking from the back, it honestly wouldn't be an issue, I don't think, if I dropped it down. But obviously the Bda engine mount does make it easier, but the way it's sitting there now, plenty of clearance, everything bolts up. So, you know, it's set up perfectly to be able to properly adjust the wastegates when the time comes, when it's all set up for final assembly. We'll be able to preload both the wastegates and then check them for correct operation so that they're properly synchronized together, just with a bit of air pressure and a pressure gauge. While I've got you here, folks, while we're looking at this part of the engine, I'll just tilt this over a bit. So this is the power steering pump that I've got on there, folks. It's a naturally aspirated power steering pump. Originally this had high gas, so it had like the really long twin turbo pump on it. And so I got hold of a pump, and I also got hold of a reservoir off an NA vehicle. And I didn't end up with any brackets or anything for the pump, and I thought, ah, bugger. You know, the NA pump doesn't fit on the twin turbo bracket, and also the pulleys are different. There's a 4-rib pulley on the twin turbo pump, and there's a 3-rib pulley on the NA pump. And yeah, all the adjustment brackets and that are different. I thought, ah, bugger, you know, now I've got to buy all the brackets. And I thought, oh, I wonder if I can modify the twin turbo bracket to accept the non-turbo pump, and just swap the the pulley over and retain all the original TT bracketry and everything to make it just kind of work. So I had a good look at the pump, and the front stage of both pumps is actually identical. So the setback with the pulley and everything is the same if you use the right brackets and stuff on it. So what I've done is I've switched the twin turbo bracket, this one here that sort of wraps around and goes onto the adjuster. It's off the TT Hikers pump, and the pulley is off the TT Hikers pump. It just goes straight on, same size shaft and everything. And the biggest issue was I had to modify the main bracket here, and what that involved doing was there's normally a recess in this position that fouls with the NA pump, where this bolt that holds it on to the bracket goes through and fixes in, and then the rest of the pump sort of goes on behind it, so it sits in a little recess. So what I did was I ground off the section that the pump normally mounts to, and then made my own piece and just milled a little slot sort of in the back of the bracket there, and just bolted that through in behind with some Allen head bolts. And I actually left the original piece on there before mounting this, so I was able to use the hole in the original bracket to get the alignment for this where this bolt goes through, because that's actually threaded in there. So that's the piece that I made up there, folks. That's sort of what I came up with. Like I say, it's just slightly milled into a little recess that I created in the main bracket and threaded, and it's got some countersunk Allen head bolts that hold it in from the other side. It's very robust. I can't see there being any problems with it. I don't think I've weakened the bracket too much. There is a lot of leverage against it in that spot, but I'm pretty sure it should be strong enough to sort of hold up to it. Considering it's made to actually take the weight of the bigger pump and everything, so there's a lot less weight on it in that regard. And yeah, it all lines up. It all lines up really well, which I was very happy with. I've sort of checked the alignment with the pulley that it runs off against, with the like the crank pulley and everything, and yeah, it works really well. So if you are doing this conversion and you have a pump but you don't have any of the brackets, have a good look at your TT bracket and everything, and if you've got access to you know, a mill or a drill press that's able to do a little bit of milling, you can quite easily duplicate what I've done there and get yourself out of trouble. I think it's going to work great. So that's this video pretty much done, folks. I hope you liked that little bit of internal wastegate tech and all that sort of stuff, and the little bit of a mod to the power steering pump there, and yeah, hope you enjoyed it. So as always, folks, thanks for stopping by the Aussie Shed. Always a bloody pleasure to have you here. If you like the video, give it a thumbs up. If you like my content, remember to subscribe to the channel and hit the bell so you get notifications of any new videos. And as always, folks, I'll bloody well see you on the next one. Cheers.